So briefly today let me explain to you the power flow in the rectifier cabinet. So this is a rectifier cabinet. So and this is for Delta brand rectifier cabinet. By the way, let me first show you some of the components in the rectifier cabinet. So these are our batteries for backup batteries, and this is how our rectifier module look like. So this is how our rectifier module look like. So this is one of the Delta in the rectifier cabinet. So let me show you one by one. So this is what we call the monitoring system in a rectifier cabinet, inbuilt monitoring system in a rectifier cabinet. So this is what we call the rectifier module, the one which changes the AC to DC, and these are DC circuit breakers, as you see all of them. So the rest are AC circuit breakers, and this for signal controlling or alarm where alarms are being connected. So let me explain to you how power flow in our rectifier cabinet step by step. So power from our AC distribution board. So this is how our AC distribution board looks like. So power from our AC distribution board, when it comes, it's always being connected here. It always reaches here. So when it reaches here, as you see, we don't have any circuit breaker. So these are what we call the connector, three-phase connectors. So it is being connected from there, and then it is being taken to that switch which you see. So that switch, after being taken to this circuit breaker, the one we are seeing S1, is also connected to what we call over voltage protection. Some of them they connect to them to surge protectors for more protection. So from the surge protectors for more protection, it is again brought to these circuit breakers, single pole circuit breakers, as you see them. So that's where power comes to the rectifier module. But before being connected to the rectifier module, they always pick here a phase, and they give these external switch sockets, as you see XS1, which is external socket. And also they pick another phase they give to other external sockets, as you see here. So here you can put your other things, external sockets, fans, what. So for this socket we always use them to, now like this one, which is for AC, we always use it to connect other AC equipment like that blower, in case we want to blow here some dust when it is here. That's why we have a provision of that external socket. So now let me go back here. I'm explaining according to that circuit diagram you were seeing. I have indicated it in this video. So as you see this one, FPS1, FPS2, FPS3, these breakers are the one which supplies power from here, AC power, to this rectifier module. Are the one which supplies power to these rectifier modules, as you see even in the wiring diagram. So each module pick power from this breaker, like this module can pick from S1, this one picks from S2, this one picks from S3. So you will ask me, what about the rest? The rest of these one, they're given the other provision, like this provision, where they pick power from to this supply to this rectifier module. So from this rectifier, when power reaches this rectifier module, it is converted from AC. So you remember the AC we always use in our telecommunication site, the AC power, we use the three-phase AC power, which is ranged in a range of 415 volts. So when it comes here, it is being converted to negative 48 volts DC. That is the suitable and the standard voltage we use at the telecommunication site. So when it reaches here, this rectifier module, they always give this power to glass bar. Are you seeing that golden glass bar behind? So after converting the DC to negative, the AC to negative 48 DC, it is given to this bus bar, as those bus bar you see, and those bus bar are connected to different breaker according to the manufacturer's desire or to the owner's desire. So like this bus bar is connected to this that is the live bus bar of negative 48. So it supplies all these breakers, and each breaker it is marked like this breaker. All of these breakers are for battery, as you see, B1, B2, B3 up to B4. So they mean this battery 1, battery 2, battery 3, battery 4, so forth. And so the batteries, this is where they charge from, and from there these batteries, this is where they charge from, and from there this is where other clients are being supplied the negative 48 power. So like you see here, we have Airtel, we have Leica, we have M10. So those blue wires, even I'm going to show you the DCDB for each client. Those blue wires which we are seeing are the one which pick which pick negative 48 DC from the rectifier cabinet. So the black one wire which we are seeing behind, that one is what we call the RTN. RTN stands for the return wires, or the returning side, and it always carry 0 voltage. So the blue one is the one which carries the negative 48 voltage from the rectifier cabinet, and also the black wire is the one which carries the 0 voltage. What? The 0 voltage. Also it has its own bus bar. So some of them, they always get confused about the battery. When this battery, some of them always ask, when this battery gets power, how do they, in case of backup, in case the mains fails and the generator fails, how do they give back power to other equipment? Have you seen here? These breakers are for 4 backup of other for 4 backup batteries. Now there is another external breaker which takes power to other equipment in case of power goes off. So this is the brain. This thing you see, this is like the brain of the rectifier cabinet. As you see, it is the one which almost governs the whole of this one. This kind of thing which you see, it is the brain of the rectifier cabinet. So here it is where we connect our other alarms. So each wire you are seeing here, it goes to a different point. It means a different alarm. So this is for the monitoring system. This thing monitor the telecommunication side, monitor the generator, monitor the fire cabinet. It also monitors the grid, all our mains. So that is how the power flows that's how power flows in the fire cabinet.